Hi everyone, this is Mrs. Bustamante. This is our second video of 7.10, which talks about speciation, and we left off talking about species and how we see different species come about by different types of isolation. I want to just kind of wrap it up with a few concepts that you need to know about in this unit as well, or this section as well. So first I want to talk about types of selection, right? How do we see different parts of a group, a population of organisms get selected for, right? Because we know that, say, when we look at this population of mice and they have different fur colors. Well, why do they have different fur colors, right? Based on their genes, right, and which genes get activated and how much they produce, we see these different phenotypes. Also remember that typically lots of genes code for one specific phenotype in something like fur color. It's not typically just one gene that gives you a specific fur color. So we see a wide distribution of different fur colors in, say, these mice, right? And then over here, this is our phenotype of fur color. Over here on our y-axis, we see the frequency, right? So when we look at this, we see kind of our typical bell curve, right? This is what we look at the mice in a population. What types of fur color do we see and how much of each, right? When we look at this in the middle, we see more of this kind of light brown fur color than the dark brown or the really, really light. So when a population gets selected for, it can get selected for in a couple different ways that change what we say is the directionality or the type of selection that's happening. So if this is our starting population, we see kind of a normal distribution, we might see something that we call stabilizing selection. And what stabilizing selection does is, by natural selection, for some reason, the kind of extremes at the two ends of a population and variations get selected out for some reason. And so you see the peak population become more towards the middle, stabilize, if you will, more towards that middle. We can also see directional selection, which favors one extreme more than the other. So you might see it move to the left or to the right in one direction or another based on what is getting selected out, or shifts the distribution to one end or another. Then finally, we can have disruptive selection, and that's kind of where we select out the middle, right? And by selecting out the middle, we're seeing that one extreme or the other extreme is favorable, and so we see the population frequency increase in those two phenotypes. So those are kind of the types of selection that we can see in a population. We can also talk about the rate of speciation, right? Basically, how fast are we creating, if you will, new species, or how fast are new species being created in some way or another? And there are two models that we talk about. We talk about gradualism or punctuated equilibrium as ways that we see new species coming about. Gradualism is like over time, right? A gradual divergence over long spans of time, typically hundreds of thousands to millions of years. Big changes occur as the accumulation of small ones. So we see lots of tiny small changes, and over time those small changes will lead to a big change that causes a difference in population. And that causes a difference in species eventually, right? Ecological conditions change gradually over a long period of time. And this is kind of what Darwin thought, okay? So when we look at our gradual model, here's our morphological changes in butterflies over time, right? And eventually we see lots of small changes, small changes, small changes, and eventually we end up with two different species that can no longer mate together and produce viable offspring. Punctuated equilibrium, on the other hand, is rapid bursts of change, long periods of little or no change, and then a species will undergo a rapid change when they first bud from a parent population. Basically, changing ecological conditions are the stimulus for evolution in either instinct. But when we look at punctuated equilibrium, it's typically like a fast change. Something caused that change really quickly versus lots of little tiny small changes over time. And so when we look at the rate of which speciation is occurring, gradualism would take longer over longer periods of time, and punctuated equilibrium would be a change that happened really quickly. Also want to talk about divergent evolution. Divergent evolution is when adaptation to a new habitat results in phenotypic diversification, right? Speciation rates, can be especially rapid during times of adaptive radiation to new habitats because when new habitats become available, right? So if there's a new niche that can be filled, if there's something that fills that niche, right, we can see that speciation happen quickly because that particular niche will be filled, it won't be selected against, and it will be surviving. Adaptive radiation, a really good example of this is the finches that Darwin saw, right? We have lots of different finches. They look kind of the same, but also we saw lots of new species developed because they filled a specific ecological role based on the environment, right? So they were all in these different environments, and we can see all these different finches that started to prosper there. Something to really remember, though, when we're talking about evolution is that evolution is not goal-oriented. It's not like my goal. It doesn't have a mind. It doesn't think this is creating the perfect species, if you will, right? An evolutionary trend does not mean that evolution is goal-oriented, right? Just because we're seeing something go that way. It's just what we're seeing based on the particular environment. Surviving species do not necessarily represent the peak of perfection for any population. Even if you were to say, oh, this is the perfect population, well, it may be the perfect population right now in the given conditions, but it will still continue to change over time. There is compromise and random chance that gets involved, and so we always see populations change slightly over time, even if they appear to be really well adapted to a given situation. It's never constant, and even perfect can change over time. I hope this was helpful, and I hope you have a great day.